Hello students, welcome to Educate. In the last class, we have discussed about the preparation of alcohols and phenols. In this video, we will discuss about the properties of alcohols and phenols. So first of all, physical properties, then after we will discuss about the chemical properties. In physical properties, usually we consider about 3 points. That is boiling point, melting point and boiling point, and solubility and the density. So firstly here about the melting point and boiling point. As we have discussed in the earlier classes, I have told you the order of boiling point when the number of carbon atom in the molecule will be same. And in that case, I have informed you that among which are in your syllabus, the carboxylic acid possesses highest melting point and boiling point, and then after is alcohol. But what's the reason? Reason is that the alcohols and phenols possesses high boiling point than that of a number of other organic compounds, because the alcohol molecules are bonded with each other through hydrogen bonding, which is the strongest intermolecular bonding. As we know, hydrogen bonding is the strongest intermolecular bonding, and the alcohol molecules are bonded with each other through hydrogen bonding. That's why the alcohol molecules possesses very high melting point and boiling point. How's the hydrogen bonding is here? Let's see. In short, I have informed you also, like this ethanol here. This ethanol molecule, here another ethanol molecule. There is a 2 lone pair phaeton at the oxygen here. Obviously, the valence electron of oxygen have is 6, out of which the 2 electron has been involved in bond formation. So other 2 will be non-bonded, which will be called lone pair phaeton. So here will be hydrogen bonding. So this hydrogen of this oxygen will be bonded to this oxygen. And same here, hydrogen of this alcohol will be bonded to this oxygen. So in this case, the number of molecules will be bonded here. Since these molecules are tightly bonded with each other, so to separate this molecule from this molecule, high amount of energy will require, because force of attraction operating between these molecules are strong. As a result, we will have to provide greater amount of heat energy to separate the molecules. That's why the alcohols and phenols possesses very high melting point and boiling point. Okay. Same is about the solubility. Now here also, that is the in this molecule here in the book also that has been shown. Here this alcohol molecule, here oxygen and hydrogen. This alcohol molecule, this is alcohol molecule, here alcohol molecules. So they are bonded with each other through this hydrogen bonding, this hydrogen bonding, here hydrogen bonding. So that's why that possesses very high melting point and boiling point. Same here in phenol. Here oxygen and hydrogen is bonded. The oxygen and hydrogen of this phenol and this phenol are bonded through hydrogen bonding. Same, this phenol is bonded to this phenol through hydrogen bonding. So hence it possesses very high melting point and boiling point. Next point is about the solubility. So what happened? The alcohol molecules are soluble in water, because it could do hydrogen bond formation with water molecule. The interesting facts about the alcohol is that they are soluble in water as well as in organic solvent also. As for example, I am telling you about in our day-to-day life, or the Indian government is also thinking about to rid out the scarcity of fuels, that is particularly of the hydrocarbon, that is petroleum. Petroleum, that is petrol, diesel, they are the hydrocarbons, and that is here, that's uses as a fuel. So nowadays the government is considering about the alcohol as a fuel. So what happened here, the 20% alcohol, that is ethanol, will be mixed with petrol and that will be used. So that will be used as a fuel. So the government can read out from the scarcity of fuels. So much costing is there in the India. I will not tell anything about this cost and price, about the price like that. In political scenario, I shall not comment. But here, but government is considering about that alcohol, to use the alcohol as a future fuel. So 20% of ethanol will be mixed with the petroleum product, petroleum, that is petrol or diesel, and then after that the scarcity of fuel could be read out through some extent. So that is here. So that is possible only when the alcohol will be soluble in. So from that point, you may think that alcohol is soluble in petrol also. So alcohol is soluble in water as well as in organic solvent. So why alcohol soluble in water? Because that can do hydrogen bond formation with water molecule. This water molecule, here alcohol, here water molecule, here water molecule. So watch out here that this alcohol molecule, the hydrogen of this alcohol, will be bonded, will do hydrogen bond formation here with this water molecule. This water molecule is also hydrogen of this water molecule is bonded to this oxygen. So here is hydrogen bonding. Here this hydrogen is bonded to this oxygen. So alcohol is soluble in water. And why it is soluble in organic solvent? Like, so there will be alkyl part like this one here, and hydrocarbon there will be, suppose octane. So that will, there will be force of attraction between these one. So that's why the alcohols are soluble in organic solvent also. The alcohols are soluble in water because alcohol molecules do hydrogen bond formation with water molecule, and hence that is soluble. Alcohols possess high melting point and boiling point because the alcohol molecules are bonded with each other through strong hydrogen bonding. So that is here. Now about the solubility, that's discussed. Now let's see this question. So I have told you here, okay, in the last class also you are aware that if there will be branching, the shape of molecules will be approach towards the sphere. So surface area of the molecules will decrease, and hence the van der Waals force of attraction operating between the molecules will decrease. So in case of isomeric alkane, the linear chain in case of isomeric alcohol also, alkane also, the linear chain alcohol will possess greater boiling point than that of branch chain alcohol. That means linear chain alcohol will possess greater melting point and boiling point than the branch chain alcohol. Okay, so let's see here to solve this question. Structure, draw the structure, then you will be comfortably draw the structure. You will comfortably compare. So pentane 1 all. So here this one, butane 1 all. Butane 2 all, so that will be bonded to secondary carbon atom. So obviously in this case, this one has least molecular weight, so it will be its possesses least. That means methanol will possesses least boiling point. Second one will be here ethanol, because here, then after here this one. Now here is butane 2 all and butane nol. So here it's the linear, it's the branch. So that's why it will possess. That means butane 2 all will possess less boiling point than that of linear chain alcohol, and then after is this. So that is the order. So that will be methanol firstly, that's written here. Okay, same here in second B. So now let's see here. Firstly, consider about that. So carbon number here goes on the carbon number. Here this one here 5 carbon, here 4 carbon. So it's a hydrocarbon. So its boiling point will be list. Then after this here, among here 4 carbon, no 3 carbon, here 4 carbon. So it will be 2. Here 4 carbon and here also 4 carbon. But it's the linear, it's the branch. So that means it's the branch chain alcohol possesses less boiling point. So that's why third will be that, fourth will be that. And now, not butane, pentane one all, pentanal. Sorry guys, here is pentanal, not this one. To solve this question separately. There was, I did the mistake. Here, I am drawing the structure freshly. So first one is pentanol. So draw the structure directly. It's normal butane. Then after is pentanal. Pentanal it is here. So pentanal means aldehyde it is. It is aldehyde. Then after is ethoxyethane. Now you know already the hydrocarbon possesses least melting point and boiling point. So that's why butane will possess least melting point and boiling point. Then after halogen, then after ether. So ether here second. Then after it's aldehyde and it's alcohol. So that's why it will be this one. So in this manner that will be the order of boiling point. Okay. For that I have also informed you in the chapter of halogens and haloarenes. If feeling difficulty, then firstly goes on that. Watch out that video firstly. Then after, even though there should not be the difficulty, but even though facing any difficulty or have any queries, then consult to the educate. Now let's see chemical reactions. Chemical reactions of haloalkane and haloarene. About that, let's see what is here. In case of alcohol, there will be two types of chemical reaction. Since it's the alcohol here, suppose this compound, so there will be, it will show two types of reactions. In one type of reactions, there will be cleavage of oxygen hydrogen bond. That means the alcohol will show one type of reaction due to cleavage of oxygen hydrogen bond, and the other reaction it will show by cleavage of carbon oxygen bond. So when there will be cleavage of carbon oxygen bond and when there will be cleavage of oxygen hydrogen bond, so let's see here. There is also when there will be carbocation here. Carbocation means here positive charge, and there is a lone pair effect on the oxygen atom. So basically carbocation will attract towards this oxygen. So this electron will attract this positively charged carbon atom. So this carbon will come here. So here will be hydrogen bonded here and this carbon. So this bond will form between this carbon and this oxygen, and there will be dissociation of this OH bond. So there is dissociation of this bond here. Between the oxygen and hydrogen bond has been dissociated, and this carbon and oxygen, the bond has been formed. And then after hydrogen will be released from there. So H plus released. So here when carbocation has approached towards the oxygen of, when carbocation will react with alcohol, simply here, when there will be during the reaction, if there will be carbocation, then that positively charged carbon will attract towards the oxygen, and there will be dissociation of oxygen hydrogen bond, and hydrogen will release as H plus ion. So in this case, alcohol will behave as acid. Okay. Now comparison, if you will have to compare which will be more acidic, which will be less acidic, then if the magnitude of positive charge here, negative charge will be more. If magnitude of negative charge on the oxygen atom will be more, then that will release H plus ion. About that we will have to consider. So now let's see here other one also. When there will be cleavage of carbon oxygen bond here. So when here is the H plus ion when combined here to this OH. So there is OH minus ion here, bond will form between here, this hydrogen, there will be bond formation between this hydrogen and this oxygen also. So that become OH2, and where there will be a positive charge on the oxygen. And then after the nucleophile will approach toward this carbon, because when there will be positive charge on the oxygen atom, so this oxygen will attract this sigma electron towards itself. When there will be positive charge on this oxygen atom here, on this oxygen atom there will be positive charge, because here O2 here, so this positive charge, then it will attract the sigma electron towards itself. So this carbon will have also positive charge. So electrophile, so the nucleophile will approach toward this carbon, and when the nucleophile will bond to this carbon, that time this carbon and oxygen bond will cleave. So this will release as H2O. Initially what happened, carbocation when had approached towards the oxygen, then there was cleavage of oxygen hydrogen bond and hydrogen was released. In that case, the alcohol was acted as the acid. But when this compound alcohol will be treated with acid, then H plus will get attracted toward this oxygen. So there will be formation of OH2 here. There will be formation of protonated alcohol. There will be formation of protonated alcohol. That means a positive charge will be at the oxygen atom. Now there will be positive charge on the oxygen. So this oxygen will attract the sigma electron of CO bond. It will start attracting the sigma electron of CO bond. So there will be a small amount of positive charge on the alpha carbon. So when there will be positive charge, the nucleophile will approach towards this alpha carbon, and when there will be bond formation between the nucleophile and the alpha carbon, that time there will be cleavage of carbon oxygen bond and it will release as H2O. Okay, that was when the alcohol will act as acid and when the alcohol will act as here, when there will be cleavage of oxygen hydrogen bond and when there will be cleavage of carbon oxygen bond. That was. But there will be some reactions by which we will have to watch out how the reaction is taking place. So let's see here. Here comparison of acidic character. So keep in the mind, when any metals, their hydroxides or their carbonates or bicarbonate, when a metal, their hydroxide, their bicarbonate will react with alcohol, there will be cleavage of oxygen hydrogen bond. That's only keep in your mind that when the metal hydroxide and the carbonate will react with alcohol, there will be cleavage of oxygen hydrogen bond. So let's see in this case here. Sodium is reacting with here alcohol, so bond will dissociate here, so sodium will get bond. So this compound will be called here. Don't consider this one as a ionic bond. This one is actually not ionic bond. This one, oh sorry, this is not a covalent bond. This is an ionic bond. It has been shown like this. There is a negative charge on the oxygen. So sodium alkoxide form here. Same aluminium. But here what happened? Here the valency of sodium is +1. That's why only one alkoxide was bonded with the sodium. But in case of aluminium, the valency of aluminium is +3. And on the alkoxide ion, there will be -1. At the aluminium, there will be +3 charge, and at the alkoxide, there will be -1 charge. So, with one Al3 plus, the 3 alkoxide group will get bonded. So that's why 3 alkoxide group has been bonded with aluminium. Okay, same reactions with phenol here also. That's react with sodium, so that's sodium phenoxide. When NaOH, when alcohol react with NaOH, or phenol here reacted with NaOH. So what happened? The H plus ion get bonded to this OH. So that will form H2O, and Na plus will get bonded to this oxygen. So there will be formation of sodium phenoxide. Now then after is here about what I have thought it to just compare this acidic character in case of later on. So what happened here? This alcohol is a primary alcohol. In case of primary alcohol, now let's see. In case of primary alcohol, at this oxygen atom, their negative charge, it will decrease. Why it will decrease? The negative charge here, the alkyl group will donate their electron. This alkyl group will donate their electron. This is acidic. Why acidic? Because oxygen is highly electronegative element. So it will tends to attract this sigma electron towards itself. So here, this hydrogen could release as H plus ion. When the alkyl group will be there, this alkyl group will provide the electron to this oxygen. So the tendency of this oxygen to take the sigma electron of this OH bond, that will decrease. When there will be two alkyl group, so more electron will be provided to this oxygen. More electron will be provided to this oxygen. So the tendency of this oxygen to take the electron of this OH bond will decline. Same when three alkyl group. So that's again the tendency to attract this sigma electron will again decrease. So that's why tertiary alcohol will be least acidic and primary alcohol will be most acidic. So acidic character in case of alcohol, when we will have to compare, then the tertiary alcohol will be least acidic because the three alkyl group will provide electron to the oxygen. As a result, the tendency of oxygen to attract the OH bond will decrease. So the ease of release of hydrogen H plus, the ease of release of H plus will be less in case of tertiary alcohol and will be most in case of primary alcohol. Okay guys, this is the chemistry. How much you will think, that much you will feel comfort. Now let's see about this one here. About that. Okay, acidic character here, acidic of alcohol we have discussed. Then after, that is a reason why alcohol is more acidic than, why phenol is more acidic than alcohol. That's the reason here. About that we will have to discuss. 2 marks question sometimes asked in the 12th board examination, why phenol is more acidic than alcohol. So watch out here the residue structure in phenol and that of in alcohol. In case of phenol, the electron present at the oxygen atom that involves in the resonance, that goes inside the benzene, the lone pair of electron present on the oxygen atom that goes inside the benzene, that relocalizes inside the benzene, and there be positive charge on the oxygen atom. So out of here 5 resonating structure, there will be 3 resonating and not 5 resonating structure. This one is not. This one and this one is similar. So out of 4 resonating structure, there is 3 resonating structure in which there is positive charge on the oxygen. So the stress on OH bond will be very high. But when in case of alcohol, this alkyl group gives the electron to the oxygen. This alkyl group provides the electron from this side. This alkyl group provides the electron to this oxygen. The alkyl group provides electron to this oxygen. So what happened here? The tendency of this oxygen to take this sigma electron, that will decrease, and hence the acidic characteristic decrease. So in case of phenol, due to plus, here it is plus R effect. Due to plus R effect, there will be positive charge on the oxygen. As a result, the stress on sigma bond will be more. While in case of alcohol, due to plus I effect of alkyl group, the stress on OH bond will be less. So Here acidic characters, the tendency of oxygen to attract this sigma electron, that will decrease. Okay, that you should have. One point is here, that's what you have to write. First reason is that okay guys, this one which I have told you, that's I have written also. So who would like, they will write this one. Now let's see, first reason was that. Second reason is that phenoxide ion is stable. Why stable? Because the negative charge on the phenoxide ion, because the negative charge on the oxygen, that will get delocalized. So when that will get delocalized, so that will be stable. But in case of alkoxide ion is not stable. Why? Let's see here. Second reason. Phenol is here. When H plus will release from there, so there will be formation of phenoxide ion, here OH minus ion, and this electron will go inside the benzene. That electron present on the oxygen, that will get delocalized, so it will stabilize by resonance. But in case of alcohol here, after the release of H plus ion, there will be formation of alkoxide ion. Here is negative charge, and the alkyl group will also provide electron to this oxygen. So there is already negative charge on the oxygen. There is already negative charge on the oxygen, and the alkyl group is also providing the electron to the oxygen. So magnitude of negative charge on the oxygen will increase. So stability will decrease. So it will be less stable, or it will be called unstable. Unstable due to okay guys, easy. Now let's see. So that is here given. Alkoxide ion is unstable, but phenoxide ion is stable. Okay. Second reason is that. How that is stable? Because due to resonance, which you can solve very easily, which you can draw this resonating structure, you can solve, you can draw very easily. So let's see. Now watch out this question. So firstly, you will have to draw firstly you will have to draw the structure of this compound, then after you will solve very easily. So let's see here, draw the structure of with every compound and then after. So by watching also, if you will try that. Okay, firstly structure draw. Maybe you come in the stress. So firstly I am drawing the structure, then after we'll compare about the their acidic strength. Okay. As in this one, like propanol I have drawn. So directly a structure I am drawing here. You could here imagine of whom I have drawn the structure. So from here I am drawing the structure. This is 3-nitrophenol. Phenol, then after is 3-nitrophenol. Now watch out here among these one. Most stress is on this compound. So its acidic strength will be most. Then after will be here 2, here 1. So then after this one will be. So that means second will be that. Because this NO2 group, that will attract the electron towards itself. So electron of this oxygen will frequently come inside this benzene. So when that will frequently come, so there will be most stress on this OH. So the stress on OH bond will be most in case of 2,4,6 trinitrophenol. And then after it will be at here, because 2 NO2 group here is, then after here. And when you watch out about this compound here, this compound, one is here phenol also, 3-nitrophenol. Phenol was also here. So in one case here there is phenol. So in phenol here, nothing is to release the electron. So and in this case, this methyl group will provide electron. So stress on OH bond will decrease. So that's why after here third, this will get fourth position, this will fifth, and you already know that the alcohol possesses less acidic strength than that of phenol. So that will be the order. So guys, I suggest you, whenever you will have to compare, then you should draw the structure and then after should think. If you will try to mug up or something else, then you comes in the problem. That was about the acidic character. That means one was there will be cleavage of oxygen hydrogen bond. One case will be that the alcohol will react with either metal or the hydroxides, carbonates, bicarbonates of the metal. And second one is esterification. About esterification I have discussed earlier also. Or what happened here in esterification? The alcohol molecule that will react with carboxylic acid. So what happened in this case? The hydrogen releases from the OH and that will combine with this OH. So this hydrogen combines this OH. So there will be formation of H2O. Now the valency of this carbon atom, this acylic carbon atom, become destabilized, and that of this oxygen will also get destabilized. So this oxygen will bond to this carbon. So compound will be here CH3CH2. There is oxygen and this oxygen is bonded to this acylic carbon atom. So here this, and then after. Now, how to write the IPAC name of the compound? What's the IPAC name of this compound? So here oxygen, this side is no acylic carbon, and this side is acylic carbon. So which side there is no acylic carbon atom? For that we will write alkyl. And in which side there will be acylic carbon? For that we will write alkanoate. Here not the length of the carbon chain, here will be based on that chain is containing the acylic carbon or not. So here this will be that is the esterification. Okay guys, I hope this one be clear for you. Some of the reactions in which here there will be cleavage of, that means in esterification there will be cleavage of OH bond of alcohol. Let's see this compound also. So about the carboxylic acid we have already discussed. Then after let's see about this one, acid and hydride. This one, acid and hydride. Let's see. This name of this compound is here methyl, this here methyl also. So it will be called dimethyl. What happened? This hydrogen will bond to this oxygen. So bond will cleave from here or here. So when that will cleave from here, so that will become carboxylic acid. So structure will be CH3, C double bond O and hydrogen bonded. So that will be CH3, C double bond O, OH. So that's carboxylic acid form. And this oxygen, since bond has been dissociated from here, so this oxygen will get bonded to this carbon. So compound becomes so during that course, there will be a formation of, during that case, oh sorry, yes, so there is, during that case here, there will be formation of ester and here carboxylic acid. Now let's see about this compound. I hope you could also solve this question. You could find the technique. Okay, I am telling you. So here is this compound, take another. Like this one here. So very easy it is. Hydrogen will get combined to chlorine. So form HCl. So valency of this carbon, acylic carbon, become destabilized, and that of this oxygen also become destabilized. So this oxygen will get bonded to this acylic carbon. The structure will be this CH3, this CH2, and there are oxygen. So here is this oxygen, and this oxygen will get bonded to this acylic carbon, and this is bonded to this methyl. So here, what's the IPAC name? This side no acylic carbon atom, this side acylic carbon atom. So for that ethyl, and for that OH. So that is. Now let's see here about the salicylic acid. I think you should solve also from the by yourself. In this case, okay, I am drawing. Okay, I am drawing here. What's the IPAC name of this compound? Because here carboxylic acid, this one is most senior. So name of the compound will be benzoic acid, and it will be here OH is at second position, so that will be called hydroxy. So here 1, 2 it is. So name will be it's the IPAC name, and common name will be called salicylic acid. This one react with acid anhydride. Same, in this case, the hydrogen of alcohol that will combine to this oxygen, bond will dissociate from here. So that become ethanoic acid. So that became ethanoic acid, this one. And this acylic carbon atom will bond to this oxygen. So what happened here? There is oxygen attached to the benzene, and with that benzene, that oxygen, this acylic carbon atom will be get bonded, and there will be CH3. So its name will be acetyl salicylic acid, and which is called aspirin. This aspirin is analgesic, means that is painkiller, antipyretic means reduces fever, and antihistamitic. Antihistamitic means it inhibits the activity of histamine. And what's the activity of histamine? That's in the allergic reactions. One is that allergic reaction, and second role of histamine is the secretion of HCl in stomach. So this aspirin acts as, it's an important compound. This aspirin is very important compound because it will be analgesic, means painkiller, antipyretic. Antipyretic means reduces fever, and antihistamic. Okay guys, that was about the reactions of alcohol and phenol which was taking place due to the cleavage of oxygen hydrogen bond. These were the reactions which was taking place due to the cleavage of oxygen hydrogen bond. Now we will discuss about those reactions in which there will be cleavage, in which there will be cleavage of carbon oxygen bond. Okay, so let's see here about this reaction. Listen here. This one is the mixture of conc HCl and ZnCl2, that is called Lucas reagent, and it acted as the Lucas reagent is the mixture of ZnCl2 and conc HCl, and it uses to distinguish the types of alcohol, that is primary, secondary or tertiary. What is happening here? Alcohol, it is soluble in water, and haloalkane form, that is insoluble in water. So primary alcohol gives turbidity only after heating. The secondary alcohol will give turbidity within 2 to 5 minutes, and the primary alcohol don't give turbidity at room temperature. The turbidity will be given only after heating the mixture. So, and reactions in that one case, the tertiary alcohol will be most reactive. Then after second, and primary alcohol will be least reactive, because when there will be cleavage of carbon OH bond, carbocation will form, and you know the tertiary carbocation is more stable than that of secondary as well as primary. So order of stability of carbocation is tertiary the most, then after secondary, and then after is primary, which is least. So tertiary alcohol gives turbidity immediately. The secondary alcohol gives turbidity in 2 to 5 minutes, and the primary alcohol gives turbidity only after heating. So how the reaction is taking place? Suppose This compound here. So haloalkane forms only after heating the primary alcohol. That's why it will give turbidity only after heating. Okay. So one reaction was here, reaction with Lucas reagent. When the alcohol will react with Lucas reagent, there will be cleavage of COH bond. Then after this reaction with PCl5, about that reactions we have already discussed. Here also we have discussed. No, about that might be not. So watch out this reaction. Third one. Suppose this compound here that react with water in presence of H2SO4. That means dilute H2SO4 when you react. So H2O that is here. Or no, dehydration here it is. Sorry. So when alcohol will be treated with the dilute H2SO4, then what happen here? H2SO4 that releases H plus and HSO4 minus here. So this OH will combine with this H plus form H2O. Then after from here the H plus ion will release and the sigma electron will come here for double bond formation. So become H2SO4, the H plus ion released from here that will combine with HSO4 minus form H2O. Its mechanism you will have to also study. That's why I am not telling here in detail about that mechanism. I shall tell you in detail after finishing the reactions. So here this like this the reaction takes place. Dehydration means removal of water. So during that course you have seen that their water was removed during that process. Same here. Like on the place of H2SO4, you may also take phosphoric acid. H3PO4 is called phosphoric acid. This H3PO4 is called phosphoric acid. Okay. Now then after is now ease of reaction. So here tertiary alcohol most reactive, then after secondary, then primary. So when the reaction will take place, due to the cleavage of oxygen and hydrogen bond, in that case the primary alcohol will be most reactive and the tertiary alcohol will be least reactive. And when there will be reaction due to cleavage of carbon-oxygen bond, then the tertiary alcohol will be most reactive and the primary alcohol will be least reactive. If you confuse in the examination, so you consider about the stability of carbocation. In tertiary alcohol, when there will be cleavage of carbon-oxygen bond, in tertiary alcohol, when there will be cleavage of carbon-oxygen bond, then tertiary carbocation will form, which will be more stable than that of secondary carbocation or the primary carbocation. So that's why tertiary alcohol will be more reactive when there will be reaction due to cleavage of carbon-oxygen bond. Mechanism we will discuss later on. Oxidation. Oxidation means you will have to react with oxidizing agent. So this oxidation can be used to distinguish the types of alcohol. As I have taught you that primary alcohol will give aldehyde, the secondary alcohol will give ketone, and tertiary alcohol do not react with mild oxidizing agent. When a strong oxidizing agent will be taken, then there will be formation of carboxylic acid, but at some places there will be dissociation of carbon-carbon bond at some places. Let's see here. How? This is the primary alcohol. So when oxidizing agent will be taken, then hydrogen of OH and the hydrogen of alpha carbon, they will release from there. So that will form H2O. Now this oxygen will do double bond formation to this carbon, and it is at the terminal end. So that's why there will be formation of aldehyde. In case of secondary alcohol, like this, when oxidizing agent will be taken, so the hydrogen of this carbon, hydrogen of this oxygen and this carbon, that will combine to this oxygen and form H2O. So this oxygen will do double bond formation here, and it is in the intermediate carbon. That's why that will be called ketone. So that's right. When primary alcohol will oxidize, there will be formation of, when primary alcohol will oxidize, there will be formation of aldehyde, and when the secondary alcohol will form, when secondary alcohol will oxidize, there will be formation of ketone. But the oxidation of tertiary alcohol is difficult. It would react with only with a strong oxidizing agent and under vigorous condition. So there will be formation when the tertiary alcohol will react with strong oxidizing agent, then under vigorous condition, that will form carboxylic acid, but there will be cleavage of carbon-carbon bond at some places. Okay, now let's see. That was about oxidation. That has been shown here. Now then after is here about the dehydration, dehydrogenation. That is about the dehydrogenation there will be. This one reaction is dehydrogenation, and it's a type of oxidation also, because removal of hydrogen also considers as the oxidation. So same here, that will primary alcohol will form aldehyde, the secondary alcohol will form ketone, and the tertiary alcohol that will form alkene. Why alkene? What happened here? The OH of this one, that will release from there. So there will be positive charge. There will be a positive charge to this carbon atom. To neutralize this positive charge, any of the sigma electron will come here for double bond formation. So that's double bond formation took place, and there is formation of alkene. Okay guys, that was about the chemical, physical and chemical properties of alcohols. Then after we will discuss about the reactions of phenols in the next class. Here it's time, it will take time. Video will be longer. So about the reactions of phenols we will discuss in the next class. Okay, it's all for this class. Thank you, Team Educate.